Hi, this class I talk about interval estimation when we know the population standard deviation. Okay, so you know that we're in chapter 8. In chapter 8 we're building interval that might include the population mean, and we're going to be using sample data and the population standard deviation to develop these confidence intervals. Okay, so just let's talk about the concepts again one more time and understand. Again, we are developing confidence intervals for the population mean, and we have to compute the margin of error. And we compute the margin of error using the population standard deviation or the sample standard deviation. The population standard deviation is like rare to know exactly, but sometimes we know that based on historical data. We refer to this case as the population standard deviation known case when we know the population standard deviation. Okay, so this is the formula. It's very similar to the one I showed you in the video about margin of error. We have the sample mean, we have the standard error of the mean, and we have a z-value that is based on a alpha level divided by 2. Okay, so if you want to know more about the z alpha level divided by 2, watch the video margin of error. All other information is probably given in the problem. Let's take a look at one example. So Discount Sounds has 260 retail outlets throughout the United States. The firm is evaluating a potential location for a new outlet, based in part on the mean annual income of individuals in the marketing area of the new location. So we have a sample size of 36 locations. The sample mean income is $41,100. The population is not believed to be highly skewed, which means it's normal, is normally distributed. The population standard deviation is estimated to be $4,500. And the confidence coefficient to be used in interval estimation is 0.95. Okay, let me see if I have here. Remember, I showed you how to find the z-value, and I used the confidence level of 95%. So I know that a z-value associated with 0.95 or 95% confidence level is 1.96. So I know the sample size, I know the sample mean, I know the population mean, I know the z-value, so I know everything. All I have to do is plug the numbers into the formula and compute. So in this case, we're first computing the margin of error, which is 1.96, okay, and multiplied by the population standard deviation divided by the square root of n, which is the standard deviation of the sample mean. So the margin of error is 1,470. So the interval estimate for the population mean is the sample mean, $41,100, plus and minus the margin of error of 1,470, which is, as a result, 39,630 to 42,570. So this is the interval. Okay. Let me show. I can show you how to do that in Excel, but it's like very simple. Like let's compute the margin. Let me do in the middle. It's easier to. Okay. So margin of error. Margin of error. So the margin of error is based on a z-value or z-score, and the sample is the standard deviation, standard deviation of the sample mean. So the z-value, I showed you how to find. If you want to watch again, watch the video margin of error. Here's the steps. So I'm not going to repeat those steps here. The z-value is 1.96. The standard deviation of the sample mean. Also, we have a video about that on chapter 7. and I'm gonna do here very quickly. So we have the population standard deviation, which is equal to, let's take a look at the population standard deviation. Population standard deviation is 4,500. It's 4,500 divided by the square root of 36. So this is 750. Let me see what's wrong here. Okay, that's correct. So the margin of error is 1.96 multiplied by 750. I'm sorry, yeah. So the margin of error is 1,470, is the same one that we have here. We know that the sample mean is equal to, let's take a look at the problem. The sample mean is $41,100. So the lower limit of the interval is, let's do it here. The lower limit is equal to the sample mean minus the margin of error. The upper limit is equal to the sample mean plus the margin of error. So those are the same numbers we have here, 39,630 and 42,570. Okay, so this is the limits of the interval. This slide, I want to highlight this slide for you. This slide is very handy because it has the most used confidence levels, 90%, 95, 99, the correspondent alpha levels, and the z values associated with these confidence levels. So if you want to have it handy, I suggest you to print this slide, have with you, so you know if you have a problem to work on in the assignments and the confidence level is, let's say, 99, you don't have to go over all the process to compute the z-score. You can go directly to here and find the z-score associated with that. Okay, so I'm going to stop here and prepare another video about solving the problems one more time.